So here we are going to talk about I2C LCD with STM32 Nucleo using STM32 CUBEIDE. So in this session we will discuss how to interface an STM32 microcontroller with an I2C LCD module. So the LCD module we will use is a Hitachi HD44780 controller based 16 x 2 LCD module with a PCF8574 I2C interface. Okay. So firstly, I will briefly introduce you to the I2C LCD including its pinout and connection with STM32 Nucleo. Okay. So then we will move ahead and program our board in STM CUBEIDE to demonstrate some basic functionalities that we can display on the LCD. Okay. So interfacing LCD modules with microcontrollers is a common requirement in many like embedded applications. Like LCDs provide an easy to read visual output that can display various type of information such as sensor reading, status messages and user input, something like that. So however, traditional method of interfacing LCDs with microcontroller can be complex, requiring like many GPIO pins and complex wiring. This is where I2C comes in. So I2C is a communication protocol that allows multiple devices to communicate with each other using just two wires. So a clock line and a data line. So I2C is a popular choice for interfacing LCD modules with microcontroller because it requires only two pins. So simplifying the wiring and reducing the number of GPIO pins needed. So now let's talk about the basic LCD, which is 16 x 2 LCD display. This is without I2C communication protocol, right? This is just a 16 x 2 LCD. This is how it's actually look like. So the model is Hitachi HD44780. It is a popular LCD controller used in many 16 x 2 character LCD displays. Okay, so this controller is widely used due to its low power consumption, ease to use and reliability. So this supports up to 32 character, like 16 columns and 2 rows, totally 32 character, and it offers various features such as character generation, display data RAM and display on off control, something like that. So this LCD controller communicate with microcontroller through an 8-bit parallel interface or 4-bit parallel interface. So depending on the mode selected. So this is widely used in various applications such as industrial control system, consumer electronics and like automotive displays. So these are the features of 16 x 2 LCD display: low power consumption, 16 x 2 character display, supports up to 32 characters, supports alphanumeric characters and symbols, built-in character RAM for up to 8 user-defined character, 8-bit parallel interface or 4-bit parallel interface. And here I provide the 16 x 2 LCD pinout and this pin description. See, you will have like D0 to D7 is nothing but the data pin. Here you can able to see VSS is nothing but ground, VDD is the power supply, you have to provide 5 volt, and VEE is the contrast control, and RS register select. So register select pin for you if you want to select in the data mode or command mode, and then RW read or write pin, and E for enable pin, and D0 D7 if you want to go for 8-bit control in this 8-bit mode, in the sense you have to connect all those pins from D0 to D7. If you want to go for 4-bit mode, in the sense you can just omit the first 4 pins D0 to D3, you just go for D4 to D7. This is why, because you can just reduce the GPIO pins, right? And then A, which is anode of LED backlight, this is cathode of LED backlight, this ground, and this is the power supply, I mean the 5 volt. And this is I2C LCD. This model name is PCF8574 input output expander. Okay, so this is an 8-bit input output expander that communicates with microcontroller through I2C protocol. This just only need 4 pins. It is commonly used to expand the number of GPIO pins available to the microcontroller. So this can be used to interface with various peripherals including LCD displays, LED, sensor, something like that. So it is 8 input output pins that can be used for both input and output operations. Okay, so this is also designed to work at low voltage level, making it suitable for battery powered applications. So additionally, multiple devices, I mean PCF8574 devices can be connected together, providing an easy way to expand the number of input-output pins even further. So overall, this is a versatile and cost-effective solution for expanding the number of input-output pins available to the microcontroller. So here I provide the features of PCF8574. This is 8-bit remote input-output expander for the I2C bus. 8 programmable input-output pins that can be used for both input and output operations. Compatible with I2C interface operating at up to 400 kHz. Wide support voltage range from 2.5 volt to 6 volt. So low standby current consumption, making it ideal for battery powered application. Internal power on reset, suitable for various applications including industrial control system, home automation and like consumer electronics. And here you can see the pinout and its pin description. So you will have like backlight jumper, contrast adjusting, I2C address changer. You just only need to connect this 4 pins to your STM32 microcontroller, because all these pins are connected to the 16x2 LCD. So LED button, and these are the data pins, everything. Okay. And coming to this, these are all the pin description. Okay. So coming to the I2C LCD pinout, this is how it actually looks like. So the both will attached like this. So now let's start with the pinout of this display. These are 4 pins: ground pin, VCC pin, data pin and clock pin. At the back side of this LCD, you can also see a variable resistor over here. So this variable resistor is used to modify the brightness of the LCD. So this potentiometer is very handy when you are using this display module is in different light conditions. Okay. So in this session, we will build a real world project by using I2C LCD display. We will display some character, string and integer to the LCD display. We will connect the display with STM32 by using only 4 wires: VCC, ground, data and clock through this PCF8574 module. Now let's go for our IDE, and let me open a new project, STM32 project. STM32 F446 D6, which is active. I'm going to give name like I2C LCD. Next, finish. Okay, so now go to system core, RCC, enable this, and then go to connectivity, select I2C1 and here select I2C, and then go to clock configuration, select HSC, PLL clock, change this to 8 MHz and change this to 72 MHz, hit enter and save this program to generate the code. See, as we are working with I2C LCD with our STM32 Nucleo, we will require the liquid crystal I2C library. Okay, so this library will be used to access different functions that will enable us to display text, numbers on the I2C display in various ways. Now let me tell you how to include libraries in these programs. For that, go to core, go to INC. Over here you need to create new file. Okay, so over here you have to name it like liquid crystal underscore I2C dot H. Okay, so liquid crystal underscore I2C dot H. Okay, we have created successfully, and go to SRC. Okay, and here over here you have to select another, you have to create another file, liquid crystal underscore I2C dot C file. Click finish. So we have successfully created 2 files. So in liquid crystal I2C dot H, I am going to paste few lines over here. Okay, so let me paste it. I will provide this library in the downloadable part. Okay, and in C file I'm going to paste this. So you will get all these steps in the downloadable list. So just give it a read. You will easily understand all those steps. Okay, so I will provide you in the downloadables. Okay. Coming to the main.c file, here we need to add few lines over here. Okay, so after this I'm going to add the library which we need for this program. Okay, so liquid crystal underscore I2C dot h. So let me check whether we have any error or not. Okay, no error. Now we can go for integer main function, into main function, and after this I'm going to add HD44780 initialization. Instead I'm going to pass 2. So what does this means? So this function takes in only a single parameter, which is the number of rows. Mine LCD is 16 cross 2 LCD, right? So as we are using 16 cross 2 LCD, hence we have specified 2 as the parameter. So HD44780 is nothing but the module name. And after this, so after this HD44780 clear. First I am going to clear the display, and then I am going to copy this. I am going to paste, like now I am going to use set cursor, 0th column, 0th row. I want to print using print str is nothing but string. First I want to print like STM32 Nucleo. Okay, and then again I am going to set the cursor. So C should be in caps, set cursor. Now 0th column, first row, what I want to print is print string I2C LCD demo. Okay, and then I'm going to end it with a delay of 2 seconds. Okay, and after this again I am going to clear the screen, and then I am going to set the cursor in 16th column, 0th row. I am going to print a string like scroll left. Okay, so now I am going to write a for loop. So in I, which is equal to 0, I am going to initialize this with 0, and then I, which is less than 20, and I am going to make the increment. Okay, so inside over here scroll display left. This function will this particular scroll display left function will left scroll this particular string. Okay, fine. So after this I am going to give delay like 500 milliseconds is pretty much enough. Okay, and after that again I am going to clear the screen. Again I am going to set the cursor like 0th column 0th row, and again I want to print the same thing, but instead of let, here I am going for scroll right. Okay, the same thing I'm going to do it here. Okay, so the for loop, so instead of left we can mention this like right. Okay, and again I'm going to do the same thing. So let me copy this and let me paste it over here. I'm going to clear the screen. I'm going to set the cursor, and again what I'm going to do is that I'm going to print a string like let's count 0 to 10, and then I'm going to give a little delay, 2-second delay. Okay, and then I'm going to give like character string, so let's give 5 is enough. Okay, so here I'm going to add one for loop. So inside integer counter, I'm going to initialize this with 0, and then counter which is less than or equal to 10, and then counter I'm going to make the increment. Inside I2A is nothing but integer to ASCII. So inside I'm going to pass counter string, and then I'm going to pass 10. So what is this? This line converts the integer counter into a decimal string and stores the result in the string. So the base of the number system, in this case decimal or base 10. You could also use other bases like 2 for binary, 16 for hexadecimal. Here I use decimal, that's why I give base 10. So after this, I'm going to again give, let me copy this, and over here I'm going to paste this, and I'm going to use set cursor. Set cursor, instead I'm going to give like 0th column 0th row. I want to print like using print string. I want to print that particular string over here. Okay, and then I'm going to end it with a little delay. Let me give 1 second delay, that is enough. And after this for loop, I'm going to again clear the screen, and again I'm going to give set cursor 0th row 0th column. I want to print like STM32 Nucleo, and let me copy this lines, and I'm going to paste it here. 0th column 1st row, I want to print like I2C LCD demo end. This is what I want to print. We don't have to give anything inside while loop because we don't anything inside that. So let me save this and let me build this. Let's check, do we have any error or not. Yes, we have some error over here, which should be in caps. Again we have error. Okay. Cursor, I hope it's fine now. Okay, now 0 errors. So let me, before uploading, let me show you this. Okay, here I have connected STM32 with I2C LCD. We just need 4 pins. Ground has to be connected with the ground of STM32, and VCC has to be connected with 5 volt of STM32, and you have to connect the data pin and you have to connect the clock pin. So here over data is connected with, like, just a minute, this is the clock, right? So clock is connected with PA7 and data is connected with PB6. So I think because of too much of brightness you can't able to see the output over here. Let me build this program and upload this into the microcontroller, and I will show you the output. Yeah, it's uploaded. So I have already recorded the output just to show you, because you can't able to see the output properly over here, right? So this is how the output will be. See, scroll left. Let's count 0 to 10. It will print 0, 1, 2, 3 numbers like that from 10. From 0 to 10, and then it will print like STM32 Nucleo I2C LCD demo, and this is how it will print output in the I2C LCD.